In this topic, we're going to learn integration by substitution. So integration by substitution would be one method that you can apply whenever you are given a complicated function to integrate it. So by using integration by substitution, you'll find that you're going to simplify the function and you can integrate the functions easily. Okay, we look on the given example. Example number 1. Evaluate the following integral by using appropriate substitution. So you need to integrate the cos square root of x over square root of x dx. When you look on the given question, you can see that you cannot integrate the function directly. So you have to simplify it first so that you can integrate the function. Now to modify the functions, you're going to apply integration by substitution. So integration by substitution, it means that you're going to let the function in terms of u, and then you have to differentiate the function. Okay, so step number 1 would be we identify the u. Okay, to identify the u, normally when you look on the given function, u would be the one that in a bracket of a given function. So in this case, here we can see that the square root of x here would be the u. So we let u equals to square root of x. So instead of writing down u equals to square root of x, we can write the u equals to x to the power of half. So why I change the square root of x to x to the power of half? Because after this you're gonna differentiate the function. Okay, now then we move on. Once we have let u as x equals to x to the power of half, so we have here step number 2. Step number 2 would be you need to differentiate the u. So since u is equals to x to the power of half, differentiate the u means that you finding the du over dx. So differentiate the function, you're going to have 1 over 2 x to the power of negative 1 over 2. Or we can write as du over dx equals to 1 over 2 square root of x. Okay, next step, I'm going to bring the x on the right hand side. So we have here du equals with 1 over 2 square root of x dx. Then looking back on the given question, you gonna modify the du here so that it suits with the original question. So it means that the dx over square root of x you're gonna remain the dx over square root of x for the du. So we have here this dx and also square root of x here to suit with the original function. So it means that the 2 here you should bring on the left hand side so that this du will suit with the original one. Okay, so we have here 2 du equals with dx over square root of x. Okay, once we have simplified, the 2 du equals to dx over square root of x. Then we move on step number 3. Okay, step number 3 will be, you will substitute the u and also the du into the original function. So we have the original function would be integrate cos square root of x over square root of x dx. So instead of writing down, when we apply integration by substitution, it means that you're gonna change the function instead of x dx to u du. Okay, so we have here integrate cos, the cos function, you doesn't change anything because you didn't change the function itself, so it still remains as the cos. And then the square root of x here, you have changed to the u, because you have in earlier step before, you have let u equals to square root of x. So since u equals to square root of x, we're going to change the square root of x to u. Okay, the next part would be based on the derivative that you have done, you can see that the dx over square root of x here, the dx over square root of x here is equivalent with 2 du. So we're going to change it, dx over square root of x into 2 du. Okay, then we have step number 4, which is you need to integrate the u. Alright, looking back on step number 3, we have here integrate cos u times with 2 du. 2 is a constant, so we bring outside from the function. So we have here 2 integrate cos u du. Now you can see that once you have changed the x dx into 2 u du, you can see that the function is in terms of the simple one, and you can integrate the function. So integrate the function, integrate cos u, you will get sin u. So we have 2 sin u, and since it is in terms of indefinite integral, so you must add up with a constant c. And the last one would be, we have here the last one is step number 5. Step number 5 would be we substitute back the value of u. Substitute back the value of u that you have left in early step. Okay, so we have here 2 sine the u that you replace in step number 1 would be the square root of x plus with c. So this would be the answer for integrate cos square root of x over square root of x dx.